Let's discuss why many individuals in your work environment might estimate window air conditioner sizes at 1500 watts for electrical calculations, even though typical small bedroom or apartment studio units often consume only 500 to 600 watts. The key reason stems from electrical code requirements that dictate load calculations must account for the maximum potential load a circuit could experience. This proven approach ensures safety and prevents overloading. While a smaller window air conditioner, drawing in the range of 500 to 1000 watts, might be the initially installed appliance, electrical codes anticipate the possibility of a larger unit being installed at a later date. Therefore, the circuit supplying the air conditioner must be sized to accommodate a potentially higher wattage appliance. The practice of assuming 1500 watts serves as a conservative safeguard. This ensures that the circuit breaker or fuse protecting the circuit will not trip due to excessive current draw if a larger air conditioner is plugged in. Overloading circuits can lead to overheating, posing fire hazards. In many cases, a circuit designed for 1500 watts will indeed be sufficient for a typical small bedroom or apartment studio installation. However, circumstances can arise where this capacity is inadequate. Consider situations where larger window air conditioners are used, or if other high-power devices such as space heaters, refrigerators, or microwave ovens share the same circuit. In these cases, the circuit might need to be upgraded to handle the increased load. The electrical calculations prioritize safety and future flexibility. By sizing circuits based on the maximum conceivable load, you create a more robust and reliable electrical system. This proactive approach minimizes the risk of overloading, preventing potential hazards and ensuring long-term safety. It's always wiser to err on the side of caution when determining circuit sizes for air conditioning units and other electrical appliances.